September 1949, the Soviet Union detonates its first nuclear bomb. The West panics. 2 years later, Korea proves that whoever controls the air above the battlefield controls the battlefield itself. Stalin draws a conclusion that will cost billions of rubles and employ tens of thousands of engineers for 4 decades. The Soviet Union will not be second in the sky. Not in jets, not in missiles, and not in helicopters. What followed was the most ambitious rotary-wing program in history. Machines that carried nuclear weapons at sea, buried a reactor from the air, set records no one has broken since, and outlasted the empire that built them. 23 helicopters, one obsession. This is all of them. 1. Building from nothing. Mil was handed a deadline and a shed on the outskirts of Moscow. His answer was the Mi-1. It flew on September 20, 1948. A small 575 horsepower machine with space for a pilot and 2 passengers and very little else. The military ordered 15 of them. Production eventually spread across 4 Soviet factories, then moved to Poland's PZL Świdnik plant, where another 1,700 were built under the name SM-1. Roughly 4,300 Mi-1s in total. It proved almost nothing tactically. What it proved was that Mil could deliver on time. In the Soviet defense industry, that reputation was worth more than any specification. Stalin summoned both Mikhail Mil and Alexander Yakovlev to the Kremlin in autumn 1951 and gave them 12 months to design a large transport helicopter. Yakovlev's answer was the Yak-24, essentially 2 rotor systems bolted onto a single fuselage. It flew on July 3, 1952. On December 17, 1955, it set 2 world payload records, 2,000 kilograms to 5,082 meters, and 4,000 kilograms to 2,902 meters. The improved Yak-24U could carry 40 soldiers, 2 jeeps, or anti-tank guns. But persistent vibration problems that engineers never solved, combined with the arrival of the far superior Mi-6, killed the program at roughly 100 examples, the only tandem rotor helicopter the Soviet Union ever built. A fascinating dead end. While Mil was building large, Nikolai Kamov was building different. His answer was the Ka-15, his obsession with the coaxial rotor, 2 blade sets spinning in opposite directions, no tail rotor required, dated back to 1929. It flew on April 14, 1953. Compact enough to stow in warship hangars no conventional helicopter could fit. 375 were built. The Ka-15 established the Kamov formula that would define Soviet naval aviation for 60 years. Minimal footprint, coaxial rotors, and the ability to operate from ships the rest of the world couldn't use. Its importance wasn't what it could do, it was what it made possible. Korea changed everything. Watching American H-19 Chickasaw helicopters evacuating casualties and supplying forward positions in terrain no truck could reach. Soviet planners needed the equivalent immediately. The Mi-4 flew in April 1952. The first Soviet helicopter with hydraulically assisted flight controls, carrying 14 soldiers or 1,600 kilograms of cargo through rear clamshell doors. Over 3,000 were built, exported across the entire communist bloc in more than a dozen variants: anti-submarine, mine-laying, electronic warfare, airborne command post. Its design mirrored the Sikorsky S-55 closely enough that Western analysts assumed direct copying. They were wrong on the details, but not on the principle. The Mi-4 was the Soviet answer to a question America had answered first. It wouldn't happen again. Act 2. The Kamov Parallel. The Ka-18 was Kamov's proof that the coaxial formula could scale. A stretched version of the Ka-15 with a 280 horsepower engine and 4 seats, approximately 200, were built from 1957 for liaison, medevac, and observation duties. It never achieved operational significance on its own terms, but it kept the Kamov Bureau alive and funded through the years between the Ka-15 and the Ka-25. A quiet contribution to a lineage that would eventually carry nuclear depth charges across the world's oceans. Then Kamov built something that had no precedent. The Ka-22 was a convertiplane, 2 large rotors on wingtip pylons that could tilt to provide both lift and forward thrust, part helicopter, part fixed-wing aircraft simultaneously. On October 7, 1961, it set an absolute world speed record for rotorcraft at 356.3 kilometers per hour. It was designed to carry Soviet airborne troops at airliner speeds across the vast distances of the USSR. 2 fatal crashes during testing and the arrival of faster, cheaper, fixed-wing transports ended it before production began. The Ka-22 remains one of the most extraordinary aircraft the Soviet Union ever flew. Proof that Soviet rotary-wing engineering was thinking decades ahead of what anyone outside the program knew. 3. The Giants. When the Mi-6 flew on June 5, 1957, it was simultaneously the largest and, by 1961, the fastest helicopter in the world. 2 Soloviev turbines producing 5,500 horsepower each, 12 tons of internal payload. In June 1961, the American Helicopter Society gave Mil the Sikorsky Trophy for the first helicopter to exceed 300 kilometers per hour in level flight. In September 1962, Mi-6 crews set 11 world records in a single campaign. It fought in the Arab-Israeli War, the Indo-Pakistani War, Vietnam, and Afghanistan. North Vietnam used it to secretly ferry MiG fighters away from airfields before American airstrikes, hiding them in jungle clearings. 874 were built at Rostov-on-Don until 1980. The Mi-6 did everything the Soviet military ever asked of a large helicopter. Then it did more. The Mi-10 used the Mi-6's proven engines and transmission, but answered a completely different question: how to carry cargo too large to fit inside anything. 4 tall landing legs let it straddle outsized loads and lift up to 11,000 kilograms externally. A fully glazed ventral gondola gave the pilot direct visual contact with the load below, a detail that sounds minor until you are hovering a reactor component over a precision installation point in Siberia. About 55 were built. They erected oil rigs, positioned transmission towers, and placed military equipment in terrain no road would ever reach. The Mi-10 proved the flying crane concept at a scale no Western program had attempted. The V-12 was conceived because the Soviet military needed to airlift 30-ton ballistic missiles to secret launch sites across Siberia. The solution was the largest helicopter in history, a rotor span comparable to the wingspan of a Boeing 727. On August 6, 1969, it lifted 44,205 kilograms to 2,255 meters, a world record that has never been broken. It won the Sikorsky Prize. It received standing ovations at the 1971 Paris Air Show. Then satellite technology and lighter missiles made its mission obsolete before the first production order was signed. 2 prototypes were built. Both survive as museum exhibits today, monuments to an engineering achievement that arrived precisely 1 decade too late. Ast-4, the workhorse of everything. The Mi-2 was the Soviet Huey, a light twin-turbine utility helicopter designed to do everything the Mi-1 had done but faster, higher, and with twice the payload. In a unique arrangement in the entire history of Soviet aviation, all production was transferred to Poland's PZL Świdnik factory. Over 5,000 were built there, the only Soviet military helicopter never manufactured on Soviet soil. Armed variants with Malyutka anti-tank missiles gave Warsaw Pact forces organic anti-armor capability a decade before most NATO armies had anything equivalent. Designed in Moscow, built in Warsaw, flown everywhere. The Mi-8 prototype flew on June 24, 1961. The twin-engine configuration that defined the production aircraft was adopted after the initial single-engine prototype proved insufficient, a change that made it simultaneously more powerful and more survivable than any requirement it was designed to meet. Its cabin carried 24 passengers, 12 stretchers, or 4,000 kilograms of cargo. It operated without modification from Arctic cold at -50 degrees Celsius to Central Asian desert heat. Over 17,000 have been built, the most produced helicopter in history, operated by more than 50 nations and present in every armed conflict from the late 1960s onward. It was produced in over a dozen variants: electronic warfare, flying hospital, VIP transport, mine-laying, special operations. A single airframe that answered every question the Soviet military ever asked of a medium helicopter, and kept answering for 30 years after the Soviet Union ceased to exist. The Mi-17 was the Mi-8 re-engined with more powerful TV-3117 turboshafts, delivering 20% better performance at altitude and in high heat. A refinement so effective, it became the standard export version of the world's most produced helicopter. Operated by over 50 nations. In an unprecedented Cold War reversal, the United States Army purchased dozens of Mi-17 after 2001 to equip Afghan and Iraqi forces. The first time Washington had procured Russian military hardware for armies, it was training. A quiet acknowledgement that the Mi-8 family was simply the best tool available for the job, regardless of who built it. 5. The crocodile. Soviet military doctrine demanded something that had never existed: a helicopter that could simultaneously destroy tanks with guided missiles and deliver 8 assault troops in a protected rear compartment. A flying infantry fighting vehicle. The Mi-24 prototype flew in 1969 and entered service in 1972. Nothing like it existed anywhere in the world. It first saw combat in the Ogaden War of 1977–78, before Afghanistan made it infamous on every front page on Earth. Afghan Mujahideen called it the Shaitan Arba, Satan's chariot. Soviet pilots called it the crocodile for the camouflage scheme. In 1978, it set an absolute world speed record for helicopters at 368.4 kilometers per hour, a combat aircraft that was simultaneously the fastest rotorcraft on Earth. Approximately 74 were lost in Afghanistan, roughly 30 directly to American-supplied Stinger missiles that changed the tactical equation overnight. 2,648 were built and distributed among 58 countries. The Hind has participated in more armed conflicts than any other helicopter in aviation history. It is still fighting today. 6. The naval dynasty. The Ka-25 was the Soviet Navy's first purpose-built shipboard helicopter, designed to hunt American nuclear submarines, armed with torpedoes and nuclear depth charges. compact enough through its coaxial rotors to fit hangars aboard ships, too small for any conventional design. It entered service in 1966. 460 were built. Operated from the 4 Kiev-class carriers and dozens of cruisers and destroyers across 3 decades of Cold War. The coaxial rotor wasn't an aesthetic choice. It was an operational necessity, and it gave the Soviet Navy a shipboard capability the West struggled to match for years. The Mi-14 answered a question the Mi-8 couldn't. What if the Navy needed a helicopter that could hunt submarines across open ocean and then land on the water to deploy sonar directly? Mil married the Mi-8's twin-engine rotor system to a boat hull fuselage with retractable landing gear, making the Mi-14 the first Soviet helicopter with retractable undercarriage. And the result was the Navy's primary shore-based anti-submarine platform through the 1970s and 80s. Variants included a search and rescue version, a mine-laying version, and a troop transport deliberately built to conceal its anti-submarine systems from arms control inspectors. The K-27 was designed from 1969 to replace the Ka-25, while fitting within its exact external dimensions. A constraint so demanding it forced every major design decision, and one that Kamov met, while doubling the aircraft's operational capability. It flew on August 8, 1973, entered Soviet Navy service in 1982, and could detect submarines at 7 kilometers and surface ships at 30 kilometers. It became the foundation for an entire family of naval variants that would define Soviet shipboard aviation through the final decade of the Cold War. The Ka-29 kept the Ka-27's coaxial rotors and compact dimensions, but answered a completely different mission. It gave Soviet naval infantry organic fire support during amphibious operations, a forward-firing Gatling gun, 4 external hardpoints, an optional 30mm cannon, and capacity for 16 fully equipped Marines. It carried twice the troops of anything that preceded it in the assault role, while maintaining the exact shipboard footprint that made the entire Ka-27 family possible. The Ka-32 was the utility derivative of the Ka-27, stripped of naval sensors and refitted for search and rescue, firefighting, and heavy lift. 30 Ka-32s were deployed to Chernobyl in 1986 for radiation measurements and precision release of insulating material over the destroyed reactor. The coaxial rotor system provided exactly the low-speed hover precision the mission demanded. It was eventually exported to over 20 nations. The Soviet naval helicopter program had, in its final decade, produced a machine the entire world wanted. The Ka-31 was the Ka-27 airframe rebuilt around a single strategic requirement: give the Soviet fleet airborne early warning from shipboard platforms. Its solution was a 6-meter folding radar antenna mounted ventrally, rotating horizontally in flight for 360-degree coverage. The only Soviet airborne early warning helicopter. It first flew in 1987, too late for the Soviet period to see it fully deployed. The requirement it answered, low-altitude threat detection from small warships, remains one of the hardest problems in naval aviation. The Ka-31 remains the most compact solution anyone has yet produced. 7. The attack race. As the Mi-24's limitations became clear in Afghanistan, too large, too heavy, too compromised by its transport role for pure anti-armor operations, the Soviet military launched a competition for a dedicated attack helicopter. Mil's answer was the Mi-28, a conventional 2-seat tandem design with a 30mm chin turret, 16 anti-tank missiles, and none of the Mi-24's transport weight dragging it down. It flew in November 1982. The military chose the Ka-50 instead, then reversed course, then reconsidered, generating a procurement indecision that lasted 15 years and left both programs underfunded through the critical final decade of the Cold War. The Mi-28 never reached production before the Soviet Union dissolved. But every design decision made in those years, the tandem cockpit, the redundant systems, the emphasis on crew survivability, would define the attack helicopter Russia eventually settled on 2 decades later. Kamov's entry in the same competition was unlike anything the committee had seen. The Ka-50 was a single-seat attack helicopter, relying on automation to reduce the 2-man crew to 1, with a composite armor skin that was the first widespread use of carbon fiber in Russian military aviation. And for the first time on any operational helicopter anywhere in the world, a true ejection seat. Before the rocket fires, explosive charges blow the rotor blades clear of the aircraft, a sequence that happens faster than the eye can follow, and that had never been successfully engineered before Kamov did it. The Ka-50 flew on June 17, 1982, won the military competition, and received its Black Shark nickname from a 1993 film in which the 5th production aircraft, painted black for the shoot, starred in the title role. Production was ultimately limited before ending in favor of a 2-seat derivative. But the Ka-50 had already answered the question that mattered. One pilot with sufficient automation could fight a combat helicopter alone. That idea changed how every nation on Earth thought about attack helicopter design. 8. The final generation. The Mi-26 was authorized in 1971 to fill the gap left by the cancelled V-12. The brief was simple: build the most capable heavy-lift helicopter in the world. It flew on December 14, 1977, entered Soviet military service in 1983. On February 3, 1982, a gross weight of 56,768 kilograms was flown to 2,000 meters. Subsequently, 25,000 kilograms was lifted to 4,100 meters. Both records remain unbroken. The first helicopter in the world to use an 8-blade main rotor, a cargo hold nearly identical in size to that of a C-130 Hercules, a transport aircraft requiring 4 turboprop engines and a fixed wing to carry what the Mi-26 lifted on rotors alone. 30 Mi-26s responded to Chernobyl in 1986. In 2002, the U.S. Army hired one to recover 2 crashed Chinook helicopters from an Afghan mountain, the largest helicopter in the world, rescuing the second largest. And then, at the very end, Mil built something unexpected. The Mi-34 was a light piston engine helicopter, the only Soviet design of its era with a piston power plant, every other contemporary having moved to turbines years before. Its 325 horsepower Vedenayev radial engine gave it an agility at low speed that turbine designs couldn't match. It was designed for training and aerobatics. Entered service in 1993 just as the Soviet Union it was designed for had ceased to exist and was produced in small numbers. It is a footnote. But it is a footnote that says something important. Even at the end, Soviet aviation engineers were still building, still solving problems no one had assigned them, still designing machines for a future they would never fully see. By 1985, Soviet helicopter factories were delivering machines at a rate Western intelligence found difficult to believe. The Mi-8 family alone ran at several hundred aircraft per year. The combined output of the Mil and Kamov bureaus had made the ITA USSR the undisputed world leader in heavy lift and naval rotary aviation. From Mikhail Mil's first uncertain hover in 1948 to the K-50's rotor blades detonating clear of a cockpit in 1982, Soviet helicopter engineering set records no one has broken, solved problems the West hadn't identified yet, and built 23 machines that collectively changed what rotary-wing aviation meant. The Soviet Union is gone. The helicopters are still flying.